Hello, so today we'll learn how to sketch polynomials. So in order for us to sketch polynomials, we need to learn first to find how to find the degree of our polynomial. So the degree is the highest exponent here. So in this example, for y is equal to x squared plus 3x plus 2, the highest degree here, the degree here is the highest exponent. So for the first equation, the degree is 2. In the second equation, the degree is 3 because those are the highest exponents in those equations. And then for this one, which is already in factored form, so what we can do is we find all the variable x and then multiply it to each other, x times x times x times x. It will result to x to the 4. Thus, the degree of this function is 4. So once we know the degree of our function, we can determine the end behavior. So if the degree is even and the leading coefficient is positive, in this example, we have y is equal to x to the 4 plus 3x plus 4. You can see here that the degree is 4 and the leading coefficient is positive 1. Thus, the rightmost part of your graph tends to go upward and the leftmost side of your graph tends to go upward too. So we can see here in this example graph here. So this one is not the graph of y is equal to x to the 4 plus 3x plus 4. This is just for illustration. And then the next one is if the degree is even, the leading coefficient is negative. So in this example, we have negative x squared. So the degree is even, but the coefficient is a negative 1. Then the leftmost side of your graph tends to go downward, and the rightmost side of your graph tends to go downward too, as you can see in this example. And then the other condition here is if the degree is odd and the leading coefficient is a positive number. In this example, we can see here that the degree is 5, which is an odd number, and the leading coefficient is positive 1. So the behavior is that the end behavior is that the leftmost side of your graph tends to go downward and the rightmost side of your graph tends to go upward. So as you can see in this sample graph. And the last condition for our end behavior is that if the degree is odd and the leading coefficient is negative, like this one, then the leftmost side of your graph tends to go upward, and then the rightmost side of your graph tends to go downward. So after knowing the degree and the coefficient of your polynomial, we need to look for the zeros and multiplicities of the zeros. So what are zeros? So zeros or roots of a function are values of x that will make y or the function equal to 0. And then the multiplicity of zeros or roots refers to the number of times the root is associated to the polynomial. So this can be determined by the exponent. So in this video, I'm assuming that you already know how to compute for the zeros or the roots of a function. So the samples here that I will show are already factored in, so we can identify easily the zeros of the function. So in this example, we have y is equal to negative x squared times x plus 1 times x minus 2. So this one is already in factor form. So we can identify the zeros here as 0 of multiplicity 2. So this one is from the negative x squared equation. So if we substitute 0 to x here, it will result to y is equal to 0. It has a multiplicity of 2 because the exponent of x squared is 2. The next zero that we have is negative 1. So if we substitute negative 1, especially here in the x plus 1 part, it will result to 0. So it has a multiplicity of 1 because the exponent here is 1. The last zero of this function is 2. So if you substitute 2 here, it will result to 0. And the multiplicity is 1. So how do we apply these zeros and multiplicity? So these zeros and multiplicity will determine how we will draw or how the graph will behave with respect to that 0. So for example, in this first drawing, so we have uh, a single 0 here. So if a 0 has a multiplicity of 1, then the graph will just cross the that particular 0. Okay, so as you can see here, the line just crossed this particular 0. But if a 0 has a multiplicity of 2 in this second drawing, second graph, multiplicity of 2 or any higher even numbers, 2, 4, 6, 8. So if your 0 has a multiplicity of those numbers, of even numbers, then the function, the drawing of your graph tends to bounce on that particular root, thus creating a parabola-like shape here. Okay, and then last condition here, or last sample here, is if your 0 has multiplicity of 3 or any higher odd number, then the graph tends to move something like this. So this one will change its concavity on the roots itself. So if you can see here, the graph will be drawn this way, and then it will be drawn on another way on the upper right hand side. Okay, so let's try to apply those zeros and multiplicity and the end behavior. So if you're given this equation, y is equal to negative x squared times x plus 1 times x minus 2. So we've identified all the zeros and its multiplicity. And we know that this one has a degree that is even, which is x squared times x will give us x to the 4. So the degree is even, but the coefficient is negative. Okay, so if we try to check first, this one, the blue highlight here, degree is even and negative, we can assume that the end behavior tends to go like this. So the leftmost side part of your graph tends to go down, and the rightmost side of your graph tends to go down. And then after knowing that, we try to plot all the zeros. So let's start first with the 0 of multiplicity 2, negative 1 of multiplicity 1, positive 2 of multiplicity 1. So once we plotted the points here, the roots, then considering the multiplicity, we know what kind of graph to draw. So the first one, negative 1, it has a multiplicity of 1. Thus, the graph that we will draw will just cross the root, as you can see here in the drawing. So it just crossed that particular green point. So because it has a multiplicity of 1. Then the next one is 0 of multiplicity 2. So we know that the yellow dot has a multiplicity of 2. And we know that if we have a multiplicity of even number, then the graph tends to bounce on that particular point, thus having this one. Okay, so it just bounces on that particular point. Okay, the next one is 2 of multiplicity 1. So same with the 0 of multiplicity, of negative 1 to multiplicity 1, it has only 1 as its multiplicity, thus just crossing the point here. Okay, and it tends to go downward because it's on the rightmost part of your graph. So if we can check the real graph of this negative x squared times x plus 1 times x minus 2, it will look something like this. Okay, so the sketch is the same as the real graph of this equation. Let's look at another example. So we have x times x plus 1 times x minus 2 to the third power. So let's we can identify first the degree, which is odd and positive. Thus, we know that the end behavior is something like this. So the leftmost side part of your graph tends to go downward, and the rightmost side of your graph tends to go upward. Next one, we plot the zeros. So those are the zeros. And then since -1 is of multiplicity 1, same thing, that it will just cross the point. The next one that we need to graph is the 0 of multiplicity 1, so it will also cross that point only. And lastly, the 2 of multiplicity 3. So this one is the graph that is changing its concavity. So it's something like this. Okay? So if we look at the real graph of this x times x plus 1 times x minus 2 to the third power, it will show something like this one. Okay? So I hope you can now sketch your own polynomials. So it's important that you know how to compute for your zeros and you know how to factor your polynomials in order for you to know the zeros, the multiplicity, and you must be able to identify the degree and the leading coefficient of your polynomials. Okay, I hope you've learned how to sketch your polynomials. Thank you and God bless.